how to make a counter out of a 595 or 74HC 595 shift register. So I have here the circuit, the LEDs, or I have 8 LEDs, and this is going to model the effect of a CD4017 counter. But if you don't have those laying around, you have basically a shift register, you can use that as a counter. So this is the basic circuit. Let me explain it here. So I have the basics of it. This is power and ground. Pins pin 2 is the Q0 output, which this wire is going to, and then Q1 through 7 are down here on these pins 1 through 7. Then you have the shift out is pin 9, which I have feeding back into the data pin, which is pin 14. The latch pin is run back to the clock pin, which is pin 13 and 12. I'm sorry, 10 and 12, or 11 and 12. And the clock I have debounced with this capacitor and this resistor pulled to ground. And I basically have the data coming from my anemometer project, which is just generating a pulse based on this infrared sensor right there at the top. And every time the reflective surface, I have one of these cups with a reflective surface on it, which is right there. It's a white surface I just taped to it. Every time it passes the infrared sensor, it reflects from the signal from the transmitter, which is on the left, to the receiver on the right, and it makes a pulse. And I have that wire going from here into the clock of that shift register. And so that's our clock signal. The key to making it a counter is you have to seed it with the initial value. So to do that, I basically trigger the data pin with this push button, and I just need to set it up so it delivers the initial signal. So let's set that spinning, and I just have to press this when it's about to come. There you go. And now we have the initial value, which is 1. Okay, in the LEDs. And now we basically continue the signals, and it works as a counter. And it goes from 1 to 8. As long as this is providing the clock signal into pin 11, and the latch pin, which is pin 12, is run back to the clock signal. So it basically is immediate effect. You don't have to do a separate latch trigger to latch the data in. And basically the data is left sort of floating, so to nowhere. So anyway, if you want to turn it off and reset it, you just basically put a separate jumper wire to ground, and you trigger it right along the data pin. And it sort of just activates with my hand, and you take it off, and there you have it, a shift register counter. And this is using the 74HC 595 shift register. By the way, the other pins that I didn't talk about, I have pin 10, which is the master reset, going to VCC. Basically, it prevents it from resetting. And the output enable pin, which is pin 13, is going with this yellow cable to ground, which is there. So works fairly well as a counter, and it's probably no substitute for the CD4017, but it's got the same features. The key to it is to have it self-feed back. So the serial output, which is pin 9, goes right back into the data pin, which is pin 14. So works pretty well.